Good afternoon and welcome to the December series of Smart Grid Educational Webinar and concurrent seminar here at the IBM Innovation Center. I am your moderator and your speaker for today, and I am very pleased to share this information with you. It has been a collaborative effort with folks from the DNP user group, the IEC 61850 group, as well as the 62351 group, and these are all within TC57, the standards body group within the International Electrotechnical Commission. And also the DNP is mapped onto IEEE 1815 standard, and there are connections to IEC 62351 also. And we're going to get into all of that today. The main purpose of presenting this presentation to you today is to encourage you to participate more with these standards specification groups as well as the international standards bodies. And the main reason is that as we are moving into the smart grid area, we don't have such clear lines of distinction now between utility and the customer and a service provider and other stakeholder groups. So it's really important to understand the interrelationships between the standards that exist in the different domains of the electric sector. Because when you are going to create and implement a smart grid application, you will no longer be limited to one or another standard. You will actually be dealing with multiple standards, and your technology or your service offering has to be consistent with that. So through this presentation, my aim is to encourage you to explore a little more, go beyond. Now, we have several people on the call who are the subject matter experts, so I feel like I am giving a seminar on floods and NOAA is sitting in the front row. And that's good, because it's important for their work, the work that these people are doing in the various groups, to be exposed to stakeholder groups that typically don't sit on those committees. And then they can understand the issues that are associated with it. So for those reasons, I am doing this presentation. We're going to start with talking about some of the core smart grid protocols as they are focused on the utility side as well as on the customer side. Then we'll talk a little bit about the IEC TC57, the various working groups, and I will also share with you some illustrations of the architecture. And then we'll get into the individual protocols. DNP3 and 61850 are used extensively in transmission and distribution protocols. The 61850 started out focused on substation automation, but has moved on to talk about specific types of generation and distributed energy resources and distribution automation also. DNP3 has been used for many years as a T&D protocol, and it's somewhere around 75% of North American utilities use it to this day. And there are various mappings of DNP, as I mentioned, to IEEE standard, the 1815, as well as to the IEC standards. The 62351 is a set of cybersecurity controls that are provided to the TC57 family of standards, and I will talk a little bit about that. And then I'm going to provide you an overview of the Common Information Model, which for SIM is 61970, and for distribution it's 61968. And these information models allow you to have a technology and vendor agnostic way of representing information that is relevant to the grid in a way that different vendors can easily exchange information. And 61850 also has that characteristic in it in doing management of field equipment. There is a concept of an abstract object layer, and there are services that are offered. And by doing that abstraction, it is very easy to exchange information inside a substation, for instance. And then we'll get into the discussion and Q&A. I want to thank these specific individuals who have really helped me get an understanding of these various protocols. I am still in learning mode, but the main reason why I am in learning mode is because of the new task that I've been given at Penn State at the GridStar project to lead this microgrid facility. And when I look at the touch points of a microgrid, I have to understand all of these protocols in order for me to lead that group of people into doing research and reach out to the utilities, vendors, and other stakeholder groups to do the collaborative research as well as to do special projects at that facility. So this is by necessity that I wanted to get beyond just having a couple of talking points on standards and saying there are experts out there. I have to slowly cross this chasm and start sharing oxygen with these subject matter experts who are doing some amazing work. So I'd like to recognize Grant Gilchrist, Andrew West, and Ron Farquharson. They are all very active in the DNP user group. And then Francis Cleveland provided a lot of information on both the 61850 standard as well as the 62351 group. And she leads the working group 15 in TC57, which focuses on cybersecurity. And the 62351 is under that working group. And then Greg Robinson and Terry Saxton of Extensible Solutions, both of them have been very involved with multiple utilities in implementing the SIM. For all the back-end processes, I'll get a little more into that. It's very important to understand there's a distinction between real-time operations, where you would use protocols like DNP and 61850 to manipulate the settings of different pieces of equipment out in the field and also gather data from them on their status. And then SIM has the ability to take that information and put it in a business context. And so if you think of all the back-end systems like outage management system, asset management system, GIS, CIS, and so on, you need a very simple object model that can exchange information between systems without having to know which vendor it is and what particular implementation it is. The object model is abstract, and so there will be a universal vocabulary by which information can be exchanged. This is very, very helpful because it helps reduce the time it takes to implement a new application, and it also makes it vendor and technology agnostic, which is very important for investment protection. And then going beyond, I wanted to share this slide with you. This is, I'll go into full screen mode so it's easier to see. This is a very good taxonomy of smart grid standards for utilities. And as you can see, on the left side, you have the Grid-Wise Architecture Council semantics of what are the different layers. You start out with the technology in the lower layers, then you've got the semantic and the business in the middle, and then you have policies on the top. So if you look across, you can see the various standards that I'll be talking about today, and you can see how they're implemented in the various layers. And that's why this taxonomy is a very valuable tool to see where the various standards lie, which layers they address, and what types of services they rely on. And so specifically today, we're going to be talking about DNP3, and I talked about the mapping with 1815. The 61850, which, as I mentioned, started out with Substation, but now it's looking at DR and other things. And then I'm going to get into ICCP and other protocols like C37118 for phasor measurement units in a future presentation. But I felt that it was good to start with some of the core protocols and then go further out and get into more detail on some of these other protocols. 61968, as I said, SIM for distribution, and 61970 SIM for transmission. As you can see, all the various layers are defined here. And then you've got the ANSI C12, which is all the metering standard. And as you can see, it has different portions of the C12.XX series depending on which layer you're talking about. If you look towards the bottom, you see ANSI C12.18 and C12.21, which involves more on the communications and how the messages are carried. And then, of course, you have the phasor measurement unit protocol C37118, which also has a connection to 61850-90-5. So having this taxonomy is very good, because when someone tells you, I'm talking about XYZ protocol, you can go back to this. This is almost like the periodic table. You'll know which family you're in and which period you're in. You know which layer you're talking about. You know which domain within that layer you're speaking about. And also within the domain, what environment you're involved in. So having this kind of representation is very important to understand the relative connection between various protocols. These are some of the protocols that are more customer-focused, and as you can see, there is a consumer electronics standard, the CEA 700. Then you've got the 61850-7-420, which is a subset of the 61850 protocols focused on distributed energy resources. And then you have SEP 1.x and 2.0. Notice the layers are different that they address. In the 1.x, as you can see, there is an Ethernet representation, but then you've got this profile, the 1.x, which hovers on the upper layers of the OSI stack into the semantic layer. And then with 2.0, you see the connection. It's being offered on IP, as you can see. And then there are also mappings to SIM. This is going to be, again, very important. Imagine if you have a utility or an energy service company that's dealing with multiple customers. The customers will not know about SIM. They will know about SEP. So you will need to map the data from SEP into SIM so that you can do effective business reporting at the service provider. Going on further, NASB is that National Standards Board, and this is another set of standards. You have OASIS and then OpenADR. OpenADR, as you know, started out at Lawrence Berkeley Labs, and then there are commercial implementations. A company like Aquacom, I think Honeywell bought them out, started promoting OpenADR, and now it's gaining a lot of traction. So you see again this connection between OpenADR, Smart Energy Profile, DNP 61850. So if you're a microgrid, if you're running a microgrid, you have to really be concerned about all of these protocols. So this is a very good taxonomy that shows you what's happening in the different layers. And then getting into commercial buildings for HVAC systems, you've got BACnet. Of course, there are other protocols like Modbus and LawnWorks and OPC and others. And I will have one presentation focused on customer premises protocols, in which we'll talk about those also. Here is a very nice representation, and this I got from the folks over at Extensible. The various working groups within TC57 and what areas they're focused on. So you can see the green circles, they are more focused on the 61850 related protocols. You've got one for hydropower, one for distributed energy resources, and one for substation automation. You can see the SIM-related ones are in work group 13, 14, and 16. 13 is focused on EMS, which is basically transmission system-related objects. Work group 14 is the distribution management systems, so SIM for distribution, and work group 16 is for energy markets. So there are various working groups. This is an international standards development organization. Why is this so important that the various protocols be mapped to something of this magnitude? Because smart grid is not a national activity. It is an international activity. And if you are a vendor and you want to compete in a global market, it is very, very important to adhere to international standards so that you're not locked into a particular country or whatever is going on with the economy of that country. Several countries have learned this the hard way in cellular telephony, where they created a national standard, did not adhere to an international standard, and they lost market share because of that. Here is a representation with the architecture of a grid on where the various standards apply. And you can see this very nice layered picture that is showing you a typical substation, and there's the back-end systems, and then you have various systems that are connected to that substation. And if you spend 10, 15 minutes just looking at this slide, you're going to begin to understand how the various standards are mapped to the various parts of the grid. So there is a lot of logic and rationality behind this, and it's important. This is not the place where I sit and I will go through each one to show you what the connection is. But you have to first familiarize yourself with a typical grid implementation. The smart grid industry is quite large. But if you took a poll of people who are in smart grid and asked, have you ever been to a substation? You will find that maybe 20% of the people who claim to be in smart grid have physically gone to a substation. So they're relying on secondhand information of what happens over there. They just know it's there in a fence, it's back there, and there's a lot of hardware there, and sometimes, you know, there are vehicles parked outside it and something is going on. But there's a disconnect between the magic of smart grid, which is happening mostly on PowerPoint, as in the current example, and then what's going on out there in reality. And I try in my presentations to try to bridge that gap, because I think that if you want to be in the smart grid business, you have to walk a mile in the shoes of the various people in this business. I know that 20, 25 years ago, if you looked at the Japanese model in corporate Japan, if you wanted to move to the upper levels of management, you had to spend some time in the different divisions of the company before they gave you that top position. And the reason was because then you could make the appropriate decisions, because you know the pain that people go through in the various departments. So what I'm suggesting is you look at this. I'm giving this with the example of TC57 standards, but think about how many people are involved in this diagram. How many working groups are sitting tirelessly mapping things out, like they're detailing object models, they're coming up with services, they're connecting it with communication layers, they are connecting it with the databases on the back end, and trying to create a layer, if you may, of information from the most elemental device out in the field, whether it's a current transformer or a potential transformer or a voltage transformer, you know, those kinds of things. Moving it up through some kind of a process bus to an IED, then taking a bunch of IEDs and putting them at the level of a master station at the substation, then taking that to the actual master station that is in the back-end office. So there are layers, and in each one of these, having the appropriate standards that do not only data formats, but also support services, because services are as important as the data. If you don't have the appropriate services, you won't get the right data that you need in order to make a particular decision. So I'm recognizing the dozens and dozens of people that are involved here. So spend some time and look at this when I send you these slides, and start thinking about the interrelationships. And you see all the various domains are here. And you see how the 62351 is on the side. It's supporting all of these protocols. You've got the SIM, you've got 61850, you've got distributed energy resource, the works. This is known as the spaghetti diagram, and the reason why it's called the spaghetti diagram is because there are all these noodles that are connecting the various environments in the domain. So if you look a little closely, you'll see all the 7 key domains of the smart grid from the conceptual model: the generation, transmission, distribution, customer premise, the energy markets, the service provider, the operations. All of them are here. Why is this diagram important? This diagram actually is the synthesis of many diagrams. The many diagrams that were created from the use case analysis that occurred in 2009, 2010, 2011 timeframe. When those use cases were analyzed, what we found was that there were transactions occurring between 2 humans, let's say, 2 systems, a system and a human, and each one of those occurred on some interface. And those interfaces have been cataloged here. So all these U-letter things that you're seeing, there were a few people involved in creating this mapping. Why is this important? Because each communication interface has specific requirements when it comes to communication, security, and data sizes, if you may, in order to support the transaction. So if you don't know the interface, you're up in the air. You have no idea what you're talking about. So it's important to have a diagram like this. Nobody sits there and looks at this. They look at subsets of this that support the different use cases, let's say for advanced metering infrastructure, or distributed energy resources, or distribution automation, or wide area monitoring, protection, and control. Each one of those will come up with a set of use cases, and there'll be specific interfaces on which those requirements will be defined. And when those requirements have been defined, then you can go back to the standards and look at the specifications in the standards and say, do those requirements that I've come up with in my use case analysis, do they map to the specifications in the standard? Because if they don't map, then the standard needs an update. It needs some additional specifications to support those requirements that the use cases came up with. Why is that important? Because if you don't do that and you say you're compliant to a particular standard, you're not going to support the services that are needed to support that use case. So you see, there's a process. You start with the business, you analyze the business into a set of use cases. From those use cases, you distill a set of requirements for specific interfaces, which are defined here. And then you go map it to the standards that are relevant to that domain. And once you've determined that there are specifications missing, you make additions. And that's what these various user groups are doing. The DNP user group, the 61850 group, the SIM group, they're doing all that. They're taking the output of this exercise and feeding it into their various working groups with new services to support, new objects to define, and so on. Now let me get into DNP. DNP has been around for the better part of 25 years or more. It has supported transmission and distribution protocols in North America, the transactions that you need to field equipment during this period of time. And it has worked very effectively. And the reason why it works so effectively is because it puts very minimum requirements on bandwidth and processing capability on the devices. So if you think what it was like 20, 25 years ago with memory and processing capability and network capacity, we had to deal with all kinds of networks. We had radio-type networks. We had twisted pair-type networks with master-slave token passing. And then we slowly got into Ethernet. We had the big, thick cable Ethernet, and then we had the Cat5, and then fiber, and now the speed keeps getting faster and faster. But DNP addressed the needs of the utility industry very effectively by having a very simple protocol to the devices. There were different types of layouts. One, which you see on top, is a very simple one-on-one setup. You have a DNP master that's probably sitting at a control center, and then you have an outstation that typically sits at a substation, and there's some kind of network between them. Another one is the multi-drop, where you have the master station on the control center, and then you have a set of outstations in the different substations. Then there is what you'd call a hierarchical one, where you may have a master station, and it is sitting at a substation, and then there's another level above that going to the control center. Let me see if we have okay. Let me just check to see if everybody can hear me okay online. If you could just put a note in the chat window. I just want to make sure I haven't lost anyone. Anyone online? If you could just, okay, very good. Thank you. We'll go back to our full screen mode again. Here is a typical DNP3 frame. This frame shows you a header and the basic stuff that involves the source and destination address and the length of the packet and the start. All of those things are there. And then there is the payload. And in the payload, there is information about turning something on, turning something off, requesting some information, or the remote device spontaneously is providing that information. So that you could have a static information, like at a particular time you ask to say, okay, give me the value now. Or it could come when there's an event. You could have binary type information, on, off kind of thing. You could have an integer type information like kilowatt hours, for instance. They'll keep adding up to a number and then the counter resets. Or you could have analog type thing that is a decimal, something point something, in which there's a floating point type integer that is sent. So this exchange, so the protocol essentially is a set of objects, their values, attributes that you want to get from devices, and their services, get, set, those types of things. So the combination of the two creates these profiles for DNP. Here is a very nice layout of the stack. So if you see, there's the master station, and there's the user code. That's the interface for the human beings. Then there's an application layer, and what that application layer does is it takes the code that the user is providing and breaks it up into manageable number of bytes. It's either, I believe, 2048 or 4096 octets. And then the pseudo transport layer breaks it down further into a set of DNP frames, because DNP typically is like 292 octets. So you have to break the data up, and then the link layer puts it on whatever frame is going to ride to the destination, whether it's a serial interface or it's an Ethernet, or whatever the communication network is, and sends it over. And then on the other side, just the reverse happens. It breaks it up, takes off the frame, headers, connects the various fragments together, presents it to the user interface, and then you've got the various types of data. As I was mentioning, binary, analog, counter, all of those are there. So you can see that there is a certain order, there's a certain architecture, and there's a concept of peering. There are similar layers at source and destination. All of these things are very important to understand. So remember what I said about DNP. There are attributes of equipment, and there are values associated with those attributes, and there are some services that help you get information to make decisions. Now let me talk about this secure authentication add-on to the DNP. Why is this important? It's important because with so much wireless communication out there, you can have someone who could interfere in that communication and modify the data a little bit. If you don't have the luxury of encrypting everything and managing those keys of encryption, you're sending it essentially in clear text. How would you know that the data integrity is there? So that's what the purpose of the secure authentication is. And I'll get into that a little bit. So the way it works is you have a key, you take the data, and you have a hashing algorithm where you use the key with the hashing algorithm to create this message authentication code, which you then append to the message. And you send it. You don't send the keys. The destination receives the data, the whole packet, and what it does is it takes the message. It has the key because they shared it previously, or it's through a PKI infrastructure thing, and then the key is used to do the hash again on the message. And if the two hashes match, that means that the probability of someone manipulating the message in a way that creates identical hash is very low. So that means no one tampered with the data. So even though it's coming in clear text, the fact that you have this common key and a hashing algorithm that you've agreed on allows you to authenticate the data, which is very, very important. Because fuzzing of this data can slowly start affecting systems. And that is one of the threats that a lot of cybersecurity people are looking at. It's not so much a blatant attack. It's this gradual erosion of performance by data fuzzing. So having a method like this is very helpful. Here's a more graphical representation of it. And you can see how the MACs are matched, and then you know that the data is intact. Why is this important? The reason why it's important is that you don't always have the luxury of having a secure connection end-to-end. You may have in some portions a VPN between, let's say, two systems across a wide area network. You may have two devices having some kind of like a TLS type security setup. But what the SA does is it gives users on specific applications the control. So everyone can't see everything. And that is what's so important, that you may have a common node on which multiple services are supported, but based on the user, because of the key management, certain entities will be able to see information and others won't. So this is very, very important to understand, that when you have a heterogeneous network with different services, many times you can't count on the intermediate points to support these security services. So SA was created as an end-to-end, true end-to-end from service to service security. So here is site security through VPN, then device security, as I mentioned, and then application to application security. This is critical to have secure communications across a very heterogeneous infrastructure. Here are the various layers of the DNP3 SA. You can see where the authentication is occurring, and you can see how the various other security services at lower layers could be offered. The security, as I mentioned, is carried at the application layer. And so if you have these routable protocols and you're concerned about security, this is a very good way. And there is a possible upgrade to IEC 61850 in the future. As I mentioned, the various protocols for T&D are being mapped by the various working groups in order to improve interoperability, because there may be a time where utilities may have equipment, some 61850 compliant and some DNP compliant, and it's really important to have the mapping occurring at the appropriate interface. And I use the word appropriate interfaces because there is proliferation of standards. You know, just like water, if you leave it on a table, it will slowly spread. So these standards also have a tendency of spreading beyond what their original intent was. And the reason makes sense. People who are working on it are excited about it, see possibilities, and keep writing specs. Nothing wrong with that, as long as the industry agrees where the appropriate interfaces are, where one standard ends and another one begins, to support a particular application. That's more important than whether the standard is spreading or not. So here is an example of how two systems across a wide area network could be communicating with this. And you could have a variety of key management options. You could have certificates or no certificates. And I would highly recommend that you visit the DNP user group site, dnp.org, and get more information on this. Some of the issues, I mentioned about 75%. A few years ago, it was 85%. It was very high. So there is some movement towards other protocols, but 3/4, I would say, represents a lot of utilities. And so anyone who thinks DNP is going to go away in a hurry should rethink. And what we need to do is find ways in which the various protocols that are supported in transmission and distribution, like C37118, 61850, SIM, and DNP, how they're all going to coexist. What are going to be the appropriate interfaces for the data exchanges? What services are supported where? And do they support the business function? Because the final arbiter is the business function. That decides whether your protocol is working for you or not. If it doesn't have the services, then you're in trouble. So a couple of things I wanted to say about the DNP. One is that there have been some advisories out about some bugs that were found, but what the DNP Technical Committee found upon deeper review is that it was mostly non-conformance to the DNP spec. In other words, how it was being implemented at a particular utility was not in conformance with the DNP spec, and it was not an issue of the spec itself. So it's recommended that there are bug fixes available for that, and for those utilities to go ahead and correct that. There is going to be advisory coming out, they've mentioned, by the end of the year. Look for that on good coding practice. So as you implement DNP, there will be some best practices shared. And there's also talk about the DNP security posture. So if you think about certain features that are not needed for a specific application, there should be a knob that you can turn off that feature, just so that it's not another opening for a potential attack on your system. So that's what the DNP Technical Committee is looking at, is the option of moving forward to creating these knobs which you can shut off if a particular application doesn't need a certain feature, to minimize the openings for threats. And The DNP3 secure authentication is still not being widely used, and the technical committee folks recommended it and told me to tell all of you that please use it. It'll only help you. It will reduce some of those risks that are associated with networks today, especially heterogeneous networks, because it provides you a very secure channel from one end of the application to another. Let's move on to 61850 now. So 61850, again, in the IEC TC57, it was that working group 10 and a couple of others. These are the parts that are defined in the spec. You start out with high-level concepts, and then you get into things that involve the data classes, as well as the object models, and then the abstract services. All of these things are very important to supporting a 61850 implementation. I have to tell you that 61850 is a very good, very solid protocol, lots of services, but it requires a certain amount of abstract thinking on the part of a person to understand the interrelationships. It's not something that you can just sit over a cup of coffee and flip through and say, okay, I'm now 61850 conversant. Not the case. It is very serious work. And I have been going through this specification, and I have to tell you that after a while it hits you about how much people have thought before they went writing this, and how much it can support going forward, especially in distributed energy resources, and also equipment that has multiple services, and it has attributes associated with those services. This abstract object model, the layered model that 61850 has, is key to supporting such sophisticated implementations. And I'm going to show you some graphics to demonstrate my point. Here we have Goose, you may have heard of, is the generic object-oriented substation event. And then you have sample values and client-server communications. So you can see that they are supported with different layers. The rightmost one that is supported by the manufacturing messaging specification, MMS, is typically what we do when we go over the wide area network to the substation. And Goose type stuff, as you can see how it's running straight on Ethernet, allows you that 4 millisecond response time for protection within a substation. So you see how these services are being used to support different things. Key thing to understand here. But the full stack, the TCP/IP stack, can support IEC 61850 commands going across, let's say, a wide area network, as you can see in this example. Physical infrastructure, just to show you a little bit more about how the various parts connect. These merge units allow for data from multiple sources to come together and be put on this process bus. The process bus is then connected via these intelligent electronic devices to a substation bus, which is a higher speed, and then from there over a wide area network to the control center. And you see a typical architecture like this. But just look at this shaded area. When you go past one of those fenced areas, this stuff is sitting there. Well, the bigger ones, the bigger substations. So you can begin to see how much sophistication is out there in the field. These are unmanned areas, but they have very rugged devices that can handle -40, let's say in Ohio, all the way to 130 degrees in the Mojave Desert. It takes a lot. This is not the comfort of an air-conditioned data center. This is real stuff. I mean, even though I'm showing you an Ethernet bus, but if you look at that device, if you remember the American Tourister commercial with the big baboon or chimpanzee who was jumping on it, that's called NEPS compliance. Right, Chris?
Yes.
Yeah. All right. Now I'm going to show you how beautiful 61850 is. 61850 has a concept of a device, a logical device, as in this case a relay, and then a logical node, as in this circuit breaker, and then it has a functional constraint. This ST stands for like a status, and then there is LOC, which means that the status is local as opposed to remote or some other location, and then there's an attribute, the data, the ST, and then there's a value associated with it. So it's hierarchical. Notice the hierarchy in it. And I'm showing this to you as an example because now you can expand this to any piece of data off of a functional constraint, off of a logical node, off of a logical device. So you can see that you can support it down to the most granular things. If I were to use the example of a tree, there's a trunk, there's a branch, there's a little branch off of that. Off that branch, there's a fruit, and there may be something on the fruit. So you've got that whole hierarchy available. Why is this important? It's important when you do troubleshooting. Having this granular information, this configurational information, so you can imagine if you have a configuration diagram available, or in this case it'll be a file, you will know exactly when a data element comes exactly where it came from. You can even correlate them if they were coming from different places just because you know the whole extension of the data format. So this hierarchical system, now imagine this, compare this with index numbers and registers. Those served a purpose when networks were primitive, but today when we have high-speed networks and lots of processing, why not? It's like the smartphone. Look how much more function we have today compared to the cell phone 10, 15 years ago, the brick that we used to carry, right? Because we have faster processors, the form factor got smaller, we can do things. So I don't believe in an existentialist conflict between DNP and 61850, as many in the industry keep bringing it up as if it was that. I disagree. I think that DNP has a very good purpose today, now, and has been for the last 20, 25 years, and will continue into the future to do what it does best. But as more and more sophisticated services are being demanded off of devices that have more computational capability, more services, more communication network capability, it makes sense to have a protocol like this to serve it. So there will be a world in which we will coexist with DNP and 61850, which is supporting the business function. Remember what I said earlier? The business function is the final arbiter. If the business function is not supported, it doesn't matter what the protocol is. These are just a means to an end. They're not the end. So there should be no existentialist battles in the industry on means to an end. So that's the point I wanted to make in this presentation. I really encourage you to be active with both 61850 group and the DNP group to understand these more subtle issues. When you know them a little deeper, you realize there's a need for both. Here is an example, a graphical representation of what I showed you previously. You've got the physical device that's connected to the network. You've got a logical device. There's some function inside that device. Then there are a bunch of nodes. In this case, they are feeder lines, 2 feeder lines that have 3-phase flow going on. That's MMXU1 and MMXU2. And then within that, there are functional constraints. That's the MX. And then you've got data elements off of those. And there's a very clear specification of what the exact format is going to be. An integer? Is it going to be binary? Is it going to be with a floating point? Whatever it is. And there's going to be certain acceptable ranges of values that a vendor tells you that the voltage will be between this and this, or the current will be between this and this. So you have an idea when you have an object whether it's realistic or not, the value of it. And the format is well formed. You know exactly what it is. The closest thing to this, but it's not this, is the MIB, the Management information base, which is used in Simple Network Management Protocol, SNMP, that manages enterprise networks. But this is a little more sophisticated than the lexicographic hierarchy created by ASN.1, the abstract syntax notation. This is much more hierarchical and provides this function. So I would really recommend that you look at Ralph Makowitz, if that's the right way to say his name, from Cisco, SISCO, has written an amazing paper on 61850. And I would recommend that you, and he's probably on the call also, I saw him, he was registered. But he's done a really good job explaining the 61850 protocol, and you can just download it from the internet. I'm just going to go a little faster now. We have some cybersecurity profiles for distributed energy resources. This is a lot of this work Francis Cleveland is doing from Xanthus with the various working groups of NIST. And it's important to understand that there are subsets of the 62351 that are associated with addressing the cybersecurity requirements at the different layers, and this is what this diagram is about. Okay. Some of the planned work that is going on in some of the working groups of 61850, I show that to you in this table. And as you're interested, you can follow these. Again, this information was shared by Francis. And there are some diagrams about how the cybersecurity needs are different depending on the criticality of the system. And so you would require more robust security the higher the value of that asset is. So you would come up with different requirements. Why is distributed energy resource so important? Because we are moving in that direction. We're making more and more of our energy from distributed energy resources. And the main paradigm shift is when you have a highly centralized power infrastructure, you can put fences around it, you can isolate it physically from people so that it's not just logical isolation, and you can put the appropriate security controls on the ICT of the generation plant. But when it's distributed energy resources, a lot of solar farms and wind farms, unmanned places, large areas, without fencing, without anything, then you have the concern about people coming and tampering with it. So it's very important to have the appropriate, not only cyber, but physical controls in place so that you know when something is being tampered with. So this is why cybersecurity for DER has become so important, because it's becoming a bigger and bigger part of the energy mix. And this is a very nice diagram that shows you how the various protocols within the TC57 family are being mapped to the various 62351 cybersecurity profiles that are being developed in Working Group 15. I like this slide because it really begins to show you that we are addressing the cybersecurity needs of all of these T&D protocols in 62351. It makes sense to centralize it in 62351 because you don't want to keep visiting cybersecurity controls multiple times. It's much better to have a core group of people who understand cybersecurity, develop a set of controls, and where appropriate, apply them for the various standards for T&D, as opposed to each standard having its own cybersecurity exercise, if you may. There are a lot of common synergies, and so this was done wisely. And you can see all the various parts of 62351 here. Here again, the mission and scope of Working Group 15, I just spoke to you about this. It's important to deal with security end-to-end, and you see all the family of TC57 being addressed in 62351. People from different countries are involved in this, as you can see. And I showed you this in a different configuration, but it's important to see these relationships. So you can see how DNP, which is not technically an IEC standard. It's an IEEE mapping, and then, of course, DNP is its own user group. But what they did as a result of the NIST work is they came with their spec to the Working Group 15 and say, why don't you try this out for your cybersecurity requirements to see if we meet them or not? And then that Cybersecurity Working Group, CSWG of NIST, sat in close coordination with Working Group 15 to review DNP. And a set of recommendations were made, which the DNP user group took, the technical committee took, and put it into their DNP3 secure version. So now we have, that's what's so nice, is that because the community is small, people talk to each other. And it really started out with human beings exchanging this thing and saying, yeah, let's check it out. So this really ties it down even more. You don't want to leave 75% of North American utilities out in the cold because the DNP protocol is not part of the IEC family. That wouldn't make any sense. So these types of exercises help what I call human interoperability, which is sometimes even more important than technical interoperability. I'm showing you by example human interoperability. Look at the various stakeholder groups I reached out to just to put this presentation together. We need to do this. We need to cross over fences and connect with people. This is very critical for our success. And here are the various status. I'm not going to go into these details, but you will get this background information. And then there are some updates occurring within the Working Group 15. And that's what this slide is about. And there are some issues that need to be addressed. So I'm sharing those with you. And then there's a report out for Working Group 15. That's this information. And some coordination with outside entities, which is what this slide is about. And some liaison work. So this is all Working Group 15 update from Frances Cleveland of Xanthus, who leads the Working Group 15. And I really appreciate her input. Okay, so now we get into, finally, the SIM. And let's have a quick time check and see how we're doing. Okay, so in about 10 minutes of SIM, and then we can open it up for Q&A. So I've been talking around the concept of SIM since the beginning of this presentation, but it's important to understand that SIM helps you simplify the integration problem. Because previously, what would happen is any two systems wanted to talk to each other, they would map their objects to each other. So A could talk to B. But if A wanted to talk to C, they would have to create another mapping. A talking to D would be another. And then there was this problem of interoperability. So the Common Information Model helps address that by creating a vocabulary that will be common to everyone. So on the GWAC stack, if you look towards the middle of the stack, that is where the SIM really fits in. This is the area where the objects are defined, the services are defined, and this is the part that helps in the integration on the back end for the utilities of their various assets. Here is the conceptual model, and then you can see the various standards that are relevant in the transactions that occur in these different environments of these various domains. And I have spoken to some extent about these various standards during the presentation. So the role of SIM in smart grid architecture is very simple. As you can see, reducing complexity with clear, consistent semantic modeling across the enterprise, very, very important, because you don't want that M by N problem. And the data sources achieve a clear picture of data mastership in the enterprise. Again, having a universal vocabulary is important so that any time a vendor A product is removed and a vendor B product is brought in, the vendor will tell you which objects they support and which ones they don't. But the vocabulary doesn't change in the enterprise, and that's very important. And there's this concept of the canonical model, and I'll show you a diagram of that in just a sec. So here is a canonical model, and you can see how it's different before and after. You see how with the canonical model, you now have this repository in the middle, and then you have all the various systems now can talk through this language to each other without requiring this M by N problem that I show you on the left side. This is key. Now, I would recommend that you go to what's called Sim University. And it's actually a very nice tutorial. It's, I believe, over maybe 2 days. And I have borrowed slides from that tutorial, essentially. But it goes deeply into the data formats and the various services that are supported across the spectrum. So I'm just going to quickly go through that. So you see how this common language helps reduce the problem of the integration? Now you can see that it should be relevant to wherever, no matter where it came from. That's the idea of a common language. The other thing is that there are different perspectives in a utility, and there needs to be a vocabulary that makes sense to people in the various business units, let's say, of a utility. So that's what this slide is about. And again, it continues with the different stakeholder groups within the utility infrastructure. Now, here's the nice thing. We see a lot of blah, blah, blah. But what this slide is showing is that the concept of an organization, no matter where it's coming from, which function it's in, but that concept of organization is consistent. And that's what SIM allows you to do, is that it creates these universal objects which people can connect with no matter what context they're looking at. This abstraction is very important. If you just spend a moment and think about what its potential is in supporting internationally smart grid applications. This is very, very important. This idea that you're disconnecting from a vendor product or a technology by creating a universal semantic model. So there would be no inconsistencies about this organization in them, so that you have this universal model and everyone understands it in that way. Here is an example of how the various services that are there, and you can see the back end, and then you see the service provider and the asset owner, how will they all connect? Okay, now I'm going to just move a little faster. And as I mentioned, it is important to go to the resources on SIM 61850 and DNP and 62351 that you find on the internet. I'm teasing you with this information on purpose that you can go and spend some time looking at it in more detail of things that are relevant to your needs. But it is important for all of you to understand that there are very hardworking and brilliant people working in these various groups that are coming up with things to support the business needs of the various asset owners. Okay, so we've talked about this, why do we need a semantic model, but I'm providing this information to you in more detail. Here is a nice architecture that shows you where the common language fits. So you've got all these applications, and then you have these services that are connected to the infrastructure, and you have a universal language that helps you deal with the various applications. So this is just another way of showing you that representation. And these are some of the more direct applications in operations that you know of, like energy management system, outage management system, CIS, and others. And it creates this universal bus for data exchange. And no matter who publishes it and who receives it, you've got that common infrastructure. I'm just giving you more slides than I'm actually going into in detail because I want you to have these slides later to review them in more detail. And I'm going to have people from SIM and DNP and 61850 actually do the deeper technical dives in 2014 in a series of webinars on my tutorial. So we'll have organizational type webinars, but then we'll have subject type webinars. But that's what this is a teaser before the holidays, because I know you're just dying to go over these slides as Santa comes. Okay, so there are some SIM-related standards, and I'm just going to tell you that there is a group within TC57. Again, this GWAC stack is not set up for representing SIM, but it resides in this area. The last couple of slides I just wanted to show you was the architecture of SIM. It's a layered architecture, and you can see there's this abstraction area, then there's a profile by application, and then there's the actual message syntax by which information is exchanged. Understanding this layered model is very important. That when we come up with the object models, that's up at the UML layer. That's where all those specifications are made. But then they are mapped into profiles which are application specific. This is where it makes sense for different, whether it's DER or distribution automation or whatever it is. And then there's the actual coding or the actual formats of the data that are exchanged with systems. So that's what this hierarchy is about. Again, here is another more detailed example of that hierarchy. And then how is SIM applied to specific information exchange? That information you see here. And I'm going to just tell you that there is a 61970 profile for transmission that deals with all of these points: equipment, schedules, measurement specs, measurement set, topology, state variables, dynamics, and schematic layouts. So these are the areas that 61970 SIM for transmission is focused on. And then here's the working group 14, which is the SIM for distribution group. And they're dealing with all of these issues, as you can see in the diagram. Again, objects representing attributes that are important for reporting in a utility for day-to-day business. Here is the various parts of 61968 and what they're dealing with by the sub number. You see how there's -8, -7, -9. So those represent these various applications or services. And then the business subfunction for 61968, here's a diagram of that. And all of this is, they go into great detail, as I said, in the SIM University tutorial. And extensible solutions with Terry and Greg Robinson offer this university type thing from the SIM user group. Extensible is just an integrator. They're a company, a consulting company, but it's the SIM user group that has helped put this together to help understand that. And that brings me to the Q&A. We just have a few minutes. I know that this was very content heavy, so I apologize for taking longer than my normal format, but I wanted you to have these slides, and I want you to start going on the internet. There are a lot of rich resources on all of these standards that are available from the various groups, but at least you have now the map, and that when you go looking for something, you can see the interrelationships with other things. So at this point, I'm going to open it up for questions, and let's see what the questions are. So I see, wow, okay. All Right. So yes, the one was William Miller mentioned one of the architectural diagrams of smart grid protocols that was created by IEEE P2030 Task Force 3 for SG1. So I want to give recognition to that. And let's see if there are any questions. Loud and clear. Yes, yes, yes. Loud and clear. Would it be? Okay, so Charles Allen says, would it be possible to have a copy of your slides? And the answer is definitely. I'm going to be sharing these in PDF version in the next couple of days. So that's fine. And then let's see if there are some questions. Let's see. Yes. Okay. Did you consider DDS, Data Distributed Service, sponsored by OMG, Object Management Group, as a standard for microgrids? One thing that it supposedly can do is automatically discover new devices or applications, something I haven't seen 61850 support. Okay, good.
I'll be back in a little bit. I got to go next door.
Okay, good point, Christine, and we will look into this and see also what its interoperability is like with 61850. There may be some reason to implement it in a certain context in a larger 61850 environment. So definitely something to look at. And did you ever see all that normalization standards implemented in a smart grid project in US? Good question. The level of integration varies from one utility to another. What I have found is that there are large DNP shops, or there are ones that have DNP but are slowly migrating to 61850, or there are, in some cases, just completely 61850 shops. So it all depends on what the particulars of a utility are. I would say, rather than looking for one where all of these standards have been applied, to look at what are some of the new business functions that are being supported, like electric vehicle charging or distributed energy resources or things like that, and see what are the relevant standards to support those, and then go and see how are they being implemented, rather than coming up with what I would call the universal set. Because there has to be a business function to support that universal set. Why would you spend all the resources integrating stuff if there are no dollars to support the function? So, you know, we live in a free market, in a capitalistic society, so we have to justify investments with some benefit, either to the customer or to the bottom line for the shareholder of a utility, or in the case of a muni, the city, or in the case of a co-op, the board. So it's much harder to justify, you know, throwing millions of dollars on something and integrating a bunch of things without having a support for business. But I will say that as microgrids become more and more important, not only for customer premise, but also for utilities as a way of stabilizing the intermittency of renewable energy. So you basically contain the oscillation by creating a set of microgrids. Then the need for interoperability across these various standards becomes very, very important. So I would say that Jean-Pierre, or Pierre-Jean, that going forward, we will see more of these demonstrations. Okay, Joe Hughes says, do you have plans to discuss topics related to harmonization, integration, or unification of these standards, work taking place within TC57 Work Group 19? Good point, Joe. So I have been mentioning that they are being harmonized as the mapping is occurring, but it would be really nice, Joe, if you are active in Work Group 19, to come and do a presentation in 2014 on specific types of harmonization projects. I do know that there was some work going on with multi-speak and SIM, and I also know some work between SIM and 61850, and also some work between 61850 and DNP. But if you would like to come and present, you're more than welcome to do so. Okay, let us go back to the chat.
Question.
Yes.
I have heard people from IEEE that they're forming some kind of working group for something called the SUN, Smart Utility Network. I've also heard the IEEE 802.11 people working on 802.11 quote-unquote, low power, extremely low power Wi-Fi replacing Zigbee. I mean, all these things seem to indicate the resentment on the communication side of the house, expressing their view of why utility side of the house kept bringing up all these different kind of things seem to be only applicable to the utility side of the house, while leaving the consumers hung up high and dry.
Okay.
Do you
So,
see any harmonization?
Yeah. I don't see the world that way, because if smart energy profiles are going to be mapped to 61850 for field equipment management, and they'll be mapped to common information model for business reporting, then they're not being left high and dry. They're actually going to be integrated. But it has to do with level of urgency. So a utility needs to get things done quickly because their operations are dependent on it. So the time scale that's involved is different. The consumer market takes a while. Then they wander a little bit, and then they figure out something that there is demand for. You saw that with videotapes, right? You see that with LAN network, that eventually people landed with Wi-Fi. The purpose of the presentation today was to focus on application layer and semantic layer, and to some extent business context layer, the upper layers. I wasn't talking so much about the lower layers, because increasingly these protocols that I'm talking about are being carried on very regular communication networks like Ethernet and Wi-Fi and others that are being used in the customer market. So I think it would be unfair if people were to make this claim that there seems to be so much focus on utility protocols. They are actually quite seamless now. And as I mentioned, the microgrid is bringing them closer together. So what I would say is that we definitely need to focus on the lower layers and standardize them, have 2-3 flavors because it helps reduce the cost of the chips, essentially. If you only have 2-3 flavors, you can have much larger scale production and you bring the cost down. So let's say we have 2-3 flavors for the lower layers. Then it's just a matter of mapping those communication protocols to the particular applications where it makes sense. And I don't think anything is going to happen to Ethernet. It's here to stay in all forms, from 10 megabits to 100 megabits to gigabit. I think Wi-Fi is here to stay. Those who are making claims that because we can bring Wi-Fi down to lower power that somehow Zigbee is facing an existentialist threat need to revisit the smart meters of America. There are at least, how many? About 100 million meters now, nationally at least, I would say. Yeah, and most of them have a Zigbee radio.
So they're not turned on. That's the argument from IEEE side.
So there is going to be, maybe in the future, some kind of an adapter that ends the Zigbee network, and then from that adapter, a variety of protocols could be supported. If you want to charge an electric vehicle, I would say use a power line carrier. I mean, you've got the wire going to the car, you might as well use it. Why would you want to use a wireless protocol with interference, reflection, fading, and everything else, and maybe charge up your neighbor's car instead of your car? As an example. So there's a time and place for everything. Zigbee did a good job with smoke alarms, fire alarms, low power things. Easy to use. It would go to sleep, it would wake up, respond. Wi-Fi is good. If you want integration with your local area network, you want to create VLANs and all that, perfect. every protocol has its purpose. And that's why I almost laugh when I hear people having these existentialist battles. I'm like, did you look at the business context before you made that statement? So, Mike, in response to you, what I would just say is that there's going to be flux for a while. It will settle down to a few flavors in home area networks. And most probably, they will mimic what's going on in utilities and energy service companies, because vendors want to make lots of one thing, so that's really cheap. That's what I would say. Okay, the question from William Miller to, will you get into granularity of SIM protocols? In this presentation, I'm not going to, because there is, as I said, a SIM user group tutorial. And I would really recommend that you reach out to Terry Saxton and Greg Robinson and schedule some time that you can learn this to the detail, because it is such a rich vocabulary with SIM, with the object models. I've given you at a high level, told you the abstraction, the services, and what it will do generally in a utility. But if for you to have a working knowledge of SIM requires you to go through that tutorial in depth and look. I mean, if you're more interested in distribution, focus on 61968. If you're more interested in transmission, 61970. But learning that vocabulary takes time. So I will bring those subject matter experts in the future. We will have presentations on SIM, as we will of the other protocols. 61850 based on UML, as was SIM. Yes. As I understand it, you can represent it in UML. And is it ready, 61850, is it ready for distribution automation use today? I will reach out to Francis Cleveland to get you an answer on that, Ray, because it is work in progress. I don't know if the implementations are commercially available or if they're still in beta testing. So, any other questions in the room? Well.
How do we get that, SIM user group tutorial?
Yes. So, when I send you this presentation, I will include Greg Robinson's contact, and you can reach him directly. But they've done a wonderful job. I mean, I sat through this tutorial and I'm like, this is a semester-long course. Yeah, I mean, you have to understand enough computer science in order to understand the schemas and then understand the services. It's very rich, but it's rewarding, because if you understand SIM and you understand 61850 and you understand DNP, it's a tall order. But you get to a certain point where you begin to see real-time operations happening in front of you. You begin to understand how a utility actually functions, how the various parts interoperate. And you don't if you're just a guy who turns on the electricity in your house and uses it. You don't know that. You don't even know that if you read any of the popular literature, because they screen out all those details. It's only when you get into these technical documents you begin to see the richness. And some concluding remarks that I would like to make is, one, keep learning. I'm learning. You know, I challenge myself. You know, I literally put the title of topics and say I'm going to talk about it, and challenge myself to go learn about it enough to make sense to all of you. Because I know that in that process, I'm going to get to a different level of awareness. I had a certain level of awareness about DNP and 61850. But as a result of the last week or 10 days of reading and all the articles and everything, you begin to distill. And I'm still in that process of compacting that information. So I welcome all of you to go to whatever level you feel comfortable, but go beyond the level where you are, because there is a certain disconnect between the popular lure on all of this material and working knowledge, like where you can do something with it. And that's what I'm encouraging. And as part of the GridStar facility that I'm now helping do the outreach for at the Navy Yard in Philadelphia, we're all about this education and workforce development. We're trying to instill in the industry a need to go beyond what's just normal and usual.
You mentioned some utilities are rich into the DNP.
Yeah.
Do you know which utilities? Is PG&E?
Yeah, if you pick 4, 3 of them will be, and that's why it's 75%. But yes, many large IOUs are involved, including PG&E and other utilities. But remember that large utilities that have the big budgets are invested in multiple things. So they may be using DNP, but they probably have a lab somewhere where they're testing 61850. They also probably have a SIM test harness going on. You know, EPRI does a lot of work with the industry on the test harness.
Utility you're working with at near Penn State, does they get involved with the DNP?
Yes.
Protocol?
Yes. Yes. So at this point, I would like to bring this presentation to a close. Our next presentation is going to be in January, and I will send out details about that. As I mentioned, the presentation and the webcast recording will be shared with all of you who have registered. For those of you who are here physically, if you could put your email address on a piece of paper to make sure that if you're on my if you registered already, you're fine. If you haven't registered, you just came physically, then put your name here, and I will pick it up.
Is your next presentation live, or is it?
It's going to be a webinar.
Okay.
Yes. This is our last seminar here at IBM. We will not be having this series at IBM going forward. I will look at other venues from time to time, but we will be really focused on our webinars going in 2014 on various topics and going more deeper into depth. We did the survey. We are at our 2-year anniversary now.
Congratulations.
And I have to say that of the 2,500 people that I send emails to every couple of weeks, 1,200 of them have sat on my calls. So this is huge over the last 2 years. And I really appreciate your support. And some of them, including people in this room, have sat more than 25 times in the last 2 years. So I'm going to, in my next webinar, recognize the top 100 people by name and affiliation for who have attended the most webinars and seminars, one way or the other. So at this point, I would like to thank everyone and enjoy your day. And we will regroup in 2014. Happy New Year, everyone.
Happy New Year to you too. Thank you.